In this video, we're going to talk about what's called the rectangular coordinate system, or the Cartesian coordinate system, named after René Descartes, who founded a lot of these principles. So in algebra, we're often concerned with something called a function or an equation. And we often want to represent that graphically. We want to create a visual representation of that function. So we do that by creating what we call a graph. And in order to come up with these graphs, we need to first establish a coordinate system. So it's important to note this isn't the only coordinate system. And as you move through your mathematical journey, you will probably encounter other coordinate systems. But this is the most common one for what we call one variable functions. Okay. So when we're just talking about numbers, we have this concept of a number line. Okay. So hopefully we're all familiar with the concept of a number line, right? Where we usually, maybe we put 0 at the center. Maybe if we're, dealing with a different set of numbers, we might center it somewhere else. But we can put 0 at the center, and then we typically put what we call the integers on it. So to the right of 0, we put the positive whole numbers. To the left of 0, we put the negative whole numbers. And then we understand that there's numbers in between these as well, right? Like we could do, we can have 2.5, maybe we have 3.2, something like that. And to represent where a number is, to plot a number, we might say, we would put a dot there, right? So if we wanted to represent the number 3, we would put a dot right at the tick mark that corresponds to 3. If we wanted to plot the number 1/2, maybe we would put it right here, about halfway between 0 and 1/2, because that's where 1/2 would be. Negative 2.1, maybe we put right here, right? We're kind of approximating because it's hard to pinpoint exactly where something like negative 2.1 would be, but we get the general idea here, right? Now with functions and equations, we're typically, and we'll talk about what this kind of stuff means later on, of course, but we're typically looking at maybe something like this. So in this kind of equation, we have two different variables where x and y, and we'll define all of this later on, but they could represent any number. So if x is, say, 1, then y is going to be 4, right? So the point I want to make here is that we have two different variables that could have different values. So just having a one-dimensional line like this isn't sufficient. We're going to need a second line for the second variable. So in order to accommodate that, what we do is we draw a second number line essentially, but we just do it vertically this time. So we do it again right where 0 is. So now on the vertical line, we also have this same concept of like, okay, the positive whole numbers are going to go above 0. So 0 is still in the middle here for the vertical line as well. And then the positive whole numbers go above 0. And the negative ones go below. And it tends to get a little crowded here. We don't have to necessarily write out this, every single tick mark value every single time or anything like that. And this is essentially the same thing. We're just putting the horizontal number line and a vertical number line on top of each other, and this will allow us to do much more. So notice the arrows on the end of these lines, by the way. This represents that it goes on to infinity, right? So there's no end to these number lines. This could go, you could have 10,000, a million, negative a billion, whatever you want on these number lines. They're not cut off anywhere. Of course, we're usually only going to be, graphing a very small subset of that space, because we can't show every single point because there's an infinite number of points. But we can use these lines to represent, okay, we get the general idea of how the graph looks, and now this will keep going to infinity, right? So that's what these arrows mean on the end here. So this horizontal number line, we typically will call the x-axis. And this is just because, as I wrote in the equation over here, x is typically the first variable we like to use. If you're using a different variable, then you can use a different, you can give it a different name. Like if it's t, you might call it the t-axis. If it's like time, maybe you would just label it as time. Okay, something like that. And then the vertical one we would name after the other variable. Typically, the second variable we like to use is y, so we would call it the y-axis. And this kind of divides it into 4 different areas, and we call these quadrants. So this area we call quadrant 1. And then we go counterclockwise from there. Okay, so quadrant 2, quadrant 3. We use Roman numerals typically to represent this. And maybe, once we don't want to write it all out, maybe we just write Q. So maybe we just refer to them as like Q1, Q2, Q3, Q4, quadrant 1, 2, 3, and 4. So quadrant 1 is probably the most common place that we're going to be studying, because in a lot of applications, we're just concerned with positive numbers. And notice that this is the area where the x-axis has the positive whole numbers and the y-axis also has positive whole numbers. And then in quadrant 2, the x-axis has negative whole numbers, whereas the y-axis has positive whole numbers. So every quadrant has a different combination here. Okay. Probably the most important point, I would say, is the very middle here, the center. Okay, so this is what we call the origin. So I'm going to draw a second one in the bottom right here, because this one's getting a little bit crowded. So let me just draw a second one that's a little more rudimentary, so it's not going to have all these labels on it. So this middle point right here, we typically call the origin. Okay. And we call it the origin because when we're making the graphs, everything is centered around this point, and when we're coming up with these things that I keep calling points, this is where we're going to start from. So when we're going to find the point, we're going to start here and then count. We're going to count from there. So this is the origin. This is where everything is starting from. Okay. So now we can talk about these things called points I keep mentioning. So let's draw another fresh graph down here. Okay, and we'll put just the tick marks on it this time. So let's just focus on the in quadrant 1 for now, and let's just look at 3 tick marks: 1, 2, 3, 1, 2, 3. This is the x-axis. This is the y-axis. Okay. So if I put a dot right here, for example, this represents what we call a point. And let me move that down a little bit just to make it a little more accurate. It's always hard to draw by hand and make it perfect. So this dot right here, this point, this corresponds to the 3 on the x-axis and the 2 on the y-axis. So we would name this point by using a parentheses and then writing the x coordinate number first and the number on the y-axis second. Okay, so, and then if you're calling them x, not x or y, you would do the horizontal first, vertical second. Same idea. So the first number we call the x coordinate because this is the number that corresponds to the x-axis. And the second number we call the y coordinate. And together we refer to this as an ordered pair. So it's a pair of numbers with an order to it, right? You do the x first and the y second. Okay. So ordered pairs will have the general form x comma y. Okay. So we use this parentheses notation to represent it. You can talk about different coordinate systems. You can expand this to like 3 dimensions, and then maybe you have x comma y comma z. Maybe you'll explore that later when talking about 3-dimensional objects. This notation is used for other things as well, so it's important to understand the concept that it's being used in. When you talk about an interval, this notation is used as well. So, but in this context, it is just referring to where the point corresponds to the x-axis and then where it corresponds to the y-axis. Okay. So in this one, we drew the point and then gave it a name. So let's do the opposite. Let's we can just stay on this graph, I guess, actually. Let's make a point. Let's say like, I don't know, 1, 3. And then let's find where that would correspond on the graph. So we're essentially looking for the place where the x-axis is lined up with 1 and the y-axis is lined up with 3. So we could just find that point on the graph, or if we wanted to, we could start at the origin. Okay, so let's start here. And then we would move horizontally however much the x coordinate tells us to. So in this case, we would move over to 1. And then vertically, we would move however much it tells us to, which in this case is 3. And then that tells us where the point is. Okay. So it's kind of giving us like instructions of where to move from the origin in order to get to the point. And of course, that's going to end up with the same thing as just finding the point where the let me draw this out, where the x coordinate of 1 and the y coordinate of 3 are intersecting. Okay. So different ways we can think about it here. So let's do one more example now where we are not in the first quadrant necessarily, because we can do this in any quadrant, of course. So let's go ahead and look at a fresh graph here. So in terms of labeling everything, some people like to label everything just to make it very clear exactly what numbers we're talking about here. But just by default, it's kind of implied that the horizontal axis is the x-axis, the vertical axis is the y-axis. And if nothing else is written and the context doesn't, make you think otherwise, the tick marks will typically represent 1 unit. But if not, maybe we write 2, 4, 6, and every tick mark represents 2 units. Okay, so there's flexibility here. You could really do any combination here. If you're talking about numbers in the tens of thousands, maybe the first tick mark is 10,000, the second one is 20,000, third one's 30,000, and so on. And the horizontal and vertical axes don't necessarily need to have the same units of measurements either. You'll often see in statistical graphs, for example, like maybe and a lot of times also they'll only draw the first quadrant, like I have here, because that's the only one relevant to the problem. So maybe you'll have like, first of all, time on the horizontal graph, and you have like 1 second, 2 seconds, 3 seconds, etc. And then you have maybe like distance on the vertical axis. And maybe this is more of a physics graph now than a statistical graph, but maybe this is like 100 feet. And then you could write the units on the axes as well. So this is like seconds maybe. And then 200, etc. So the point is that your units, your tick mark distances can be whatever fits the problem. Basically, there's a lot of flexibility here. It doesn't just have to be one unit, because then if you have things in the hundreds or thousands, it would be impossible to draw all of that. All right. So anyway, let's just do an example where every tick mark represents 2. And usually if you just draw the first one, it's kind of implied that you're going to repeat that pattern. So like on the right graph here, if I just write 100, it's implied that every unit's going to be another 100. On this left graph here, if I write 2 for the first one, it's implied that every unit after that is going to be another 2, right? And you don't even necessarily need to write the negative side, because it's implied that it's the same on both sides of the horizontal axis, and same with the vertical axis. Okay. So the horizontal and vertical axes could be different themselves, but each side of them will typically be symmetrical. So anyway, let's just come up with a few points here and go ahead and graph them. So maybe we'll do 3, -2. Okay, so we would want to go 3 on the, so we start at the origin, and then we'll go over 3 horizontally, and then -2 vertically. So this is going to be down 2. And I'm messed up here because notice that I went past the first tick mark, but the tick marks are only representing 2 here. Let me redraw that. So our point is actually just right here, right? Because that tick mark represents 2 in our case. So this is the point, 3, -2. So let me move this label over to it. It's good practice to label your points because it's hard to draw this by hand. It might not line up perfectly, but you don't necessarily have to if it's clear from the context. Now let's go for, I don't know, maybe -5, 4. Okay, so again, we would start from the origin here. We go -5 horizontally, so that's going to bring us over to here, right between -4 and -6. And then we're going to go up to 4 vertically. So that's going to bring us right here. So we're going to draw a point right here. Now I'll move this label over here. Okay. So this is how we will find points on a graph, and this is the basis of our coordinate system.